So welcome to our Kundinger Presents session for today. Today we're going to be talking about some pneumatics technology. And so we're going to be joined by Courtney Costelli, who I'll introduce here in a minute. So Courtney, next slide.
Oh, bear with me.
So just wanted to touch base a little bit on Kundinger Inc. I think most of you are going to be familiar with us, but our areas of expertise are fluid power, industrial automation, process controls, engineered solutions. And we've got locations in Neenah, Wisconsin. That's basically where our distribution center is, our service center is, our sales, customer service, all that's kind of out of there. Auburn Hills, Michigan, that's more of our control side of things. Our process controls side of things is over there. Green Bay, Wisconsin, we've got a Parker store, Kundinger Parker store located there, and then the same thing in Sheboygan, Wisconsin. Next slide. So if you don't know who your outside sales guys are, you can contact our customer service department at the email or phone numbers below. But if you do know who your outside sales guys are, I got them all listed here. And then on the right side, I kind of show some of our main manufacturers that we represent. Today, we're going to be joined by Courtney Costelli from Parker. She's our pneumatics technology territory manager. Basically, we're going to let Courtney take the reins here and show us some new things with Parker Pneumatics. So, Courtney, you're off and running.
Good afternoon, everyone. My name is Courtney Costelli. As Joe mentioned, I work for Parker Hannafin's Pneumatic Division. I'm located up in Green Bay, Wisconsin, and I work with distribution as well as end customers in the Wisconsin and Upper Peninsula area. So today what I want to go over is sizing your valve, how to correctly do it, as well as our newer reinvented H universal valve product. I also like to touch base a little bit on network connectivity with our products, as well as a little bit of IO-Link. I've been getting a couple questions on there. And last but not least, I'd like to go over our configurator. So, sizing your valve. Why is sizing your valve important? Each one of these valve series here can have the ability with 1/4-inch ports. And at each of those 1/4-inch ports, they all have different flow coefficients. When I talk about flow coefficients, I'm talking about this CV value right here. As you can see, you can get anywhere from a 0.35 CV all the way up to a 1.1 CV, or 1.5, excuse me. And they all have 1/4-inch ports. So why is it important? You can potentially reduce your component costs. If your valve is oversized, you can waste air consumption, which generating compressed air is one of the most costly utilities in a facility. And oversizing in a manifold could also starve your other valves in the manifold. So what is a CV and how do we calculate it? A CV is based off of this equation down here. And I know that can be somewhat intimidating. So I tell you what, is there an easier way? Of course. There's an app for that. There's an app for everything, right? So if we visit this website, pdnetools.com, you're able to access our online calculator. We also have another way through the Apple Store or the Android Store, where you can download the Parker Pneumatics app right here, and you'll be able to pull up the online calculator that way as well. So what does this online calculator look like? Here is going to be your screen. Now, what we're going to be mainly concerned with today is this valve FRL sizing program. Again, if I'm going too fast, this is being recorded.
Just do this.
So when we click on this valve FRL sizing program, we're going to get a drop-down menu. Now, if you know your airflow, you can calculate your CV that way. Vice versa, if you know your CV, you can calculate your airflow. But the one that we're going to be most concerned with today is this valve FRL sizing for cylinder actuation. This is the screen that's going to pop up when you select that particular calculation. Here you can import your cylinder diameter. In this case, it's a 6-inch bore. Your cylinder stroke, 12 inches. Our stroke time, we're going to pick 1 second, and then whatever pressure you're going to be operating at. So in this case, we've picked 80 PSI. If you know your pressure drop, you can import it here, or else all of our CV values in our catalogs are all calculated using a 5 PSI pressure drop. Now, after you enter in all these variables, it's going to give you a CV value down here that you can use to correctly size your valve. Now, it's important when selecting your valve to not oversize and also not undersize. You got to hit that sweet spot in the middle. So if your application is requiring, you know, a 3.2 CV valve, or in this case, a 3.48, and you have an option between a valve that's rated for a 4 CV or a valve that's rated for a 3 CV, you're going to want to pick the 4 CV. If you pick the 3 CV, you're not going to meet that stroke time requirement. So round up. So let's talk about, when we talk about reducing component costs, let's take this specific example where we have 4 cylinders that are requiring a CV of less than 0.5, 4 cylinders requiring less, or requiring a 1 CV, and 2 requiring a 2 CV. Now, a lot of times when I visit my customers and I ask them, how do you size your valve? They go off the biggest cylinder. So in this case, they're sizing all of their valves based off this 2.0 CV. You can see how that manifold can get quite lengthy using all those H2 ISO-sized valves. So if we don't want to do that, another option would be is to break the bank up, to have the smaller valves over here and the 2 larger ones on a separate manifold. Now, you can see when we're hardwiring our valves, the cost is going to be less, around $1,300 compared to $1,900 on the last example. But our Ethernet here, if we're going to put these 2 valve banks on Ethernet, you're going to be using 2 addresses and going to need 2 communication modules compared to 1. Not the greatest way to do it, but it's still an option. Now, with our new H Universal product, you can correctly size all of your valves and keep them all on the same manifold. And you can see here how your component cost is going to be reduced from that $1,300 on the previous example, hardwired, to around $1,200. And on the previous example, where it was around $2,200, down to $1,700. And then again, you're getting your size 2, your HAs, and your HBs all on 1 manifold and all on 1 address. So when we line all of these examples up, you can see right here, we can go all the way from that $1,900, $2,300 for the Ethernet version, all the way down to $1,200 and $1,700. And that's a big cost savings if you're talking about buying a couple of manifolds a year. And that's why it's important that you correctly size your valves for your application. So now that we can correctly size our valves and we know how to do it, let's talk a little bit about this H Universal product. With the H Universal product, we're able to have a range of a 0.5 CV all the way up to a 6.0 CV on the same manifold. The only portion that's going to require a transition plate is going from this 3.0 CV valve up to a 6.0 CV. And that's just because this valve is so much larger than the rest. So when we talk about these ISO valve, what ISO necessarily means is an International Standards Organization where our valves are interchangeable with other manufacturers. Our new H Universal design, again, allows for the right sizing of your valves. We do have high flow end plate options where I can put a high flow end plate, and I have a picture of that later on. Operating temperature, pretty standard from 5 degrees Fahrenheit up to 120. And we can also handle vacuum as long as your manifold is external piloted. Again, our CV range, 0.55 to a 6.0, all on the same manifold. And this valve series is highly configurable. What do I mean by highly configurable? My customer ordered a H-series manifold where all of a sudden I need to have an external piloted valve on this manifold. What's nice with the H-series valve is that it is field convertible. So I can actually take off that solenoid, flip this gasket, and now I have an external piloted valve where I can put in a sandwich regulator. Now, one thing I also want to point out about this new H universal manifold design is it's linked together by 4 bolts. So as you can see here, 1, 2, and there's 2 on the back side. You can take this apart anywhere in between on this entire manifold, making service time so much easier because you're not dealing with all those tie rods in the previous design. Now, we also have the ability to institute these zoning gaskets, and there's a nice little indicator that pops out the back showing where that zone is. This right here is an example of our high flow end plate. So I can actually import air and exhaust air on this side separate from this side over here, and all on the same network. Now, with this H universal product, we do have other accessories that are available with it. We have independent as well as common sandwich regulators. We do have the ability to have all these different zoning gaskets. We have the ability to have an intermediate supply module if you'd like, as well as this new pilot exhaust module. This is a new product that we just recently launched in the last 2 months, and I do want to spend a little bit of time talking about it briefly. So it's used mainly in safety applications, and you import it here, or you input it on the bottom of an HA valve, which has a flow around 1.0. And right here we have 3 different versions. We have no sensor, we have a mechanical pressure switch, and we have a solid state pressure switch. And what this basically does is for this valve only, it'll return it to its, if it's a 5-way 2, it'll return it to its 12 operator state. If it's a double solenoid, it will maintain the last state. And for a 5-way 3, it'll return to the center condition. And why is that beneficial to you? Maybe when someone presses an e-stop on your machine, maybe you only want one little portion of the machine to exhaust air. Or maybe you want only one portion of the machine to stop. All the rest on the manifold will still operate. It's just pertaining to that one portion on that manifold. So let's talk about network connectivity. So I get a lot of questions. What is this IO-Link and how is it different than Ethernet? I want you to think of it as like the mailing system. Each Ethernet device has its own address. So I want you to think Ethernet as addresses. Well, that mail or that signal has to get to that house somehow. So when we talk about that transporting that signal, that's going to be our mailing network, or FedEx could be Profinet, UPS could be Ethernet, DHL could be EtherCAT. But there's a mean to transport that signal. Ethernet is like an address. A hotel is like IO-Link. So a hotel will have one address, and in that address, you have multiple sub-addresses. So here's kind of a little bit of a clearer example. Again, we're going to think of this Ethernet product as a single address like a house. And we're going to think of this IO-Link as having one address. Right here is your address. And then each one of these individual ports is like a sub-address. So I could potentially, on this particular IO-Link master, have 8 manifolds on here. And instead of having 8 addresses, I would technically only have one address with 8 sub-addresses. So let's talk about the different network communication products that Parker has to offer. We'll start by talking about our Turk product. We do have the ability to have inputs and outputs on this product attached to our H universal manifold. And these are the different protocols here that we can encompass. It's a little bit pricey, but if you do require those inputs and outputs, it can be worth it. Our H-Series network is our preferred connectivity with Allen Bradley product, meaning you can go into the Compact Logic software and pull up our information pertaining to our manifolds. You can have up to 32 outputs for the HA and HB sized valves, which are 2 smaller size, and up to 24 outputs for the H1, H2, and H3 size valves. That's your 1.1, 3.0, 6.0 CV type valves. You are able to also add input-output cards to this product. And these are the different protocols down here that our H-Series network can handle. Now, we do have this newer product that has just recently been launched to the market this past year. And we call it our P2M network node. And with this network node, we are priced to compete. We can have it on our ModuFlex product right here, and we can also have it on our H Universal product right here. The only issue with it is we don't have the ability to have additional input and output modules on here. And we are limited to 19 outputs on our ModuFlex and 24 outputs on our H micro and our larger H ISO type valves. So with that, you may need to use single address bases if you do have more than 12 valves on your manifold. These are also the different protocols that our new P2M network node can handle. A big request I've been getting for lately is this EtherCAT, which is a much faster protocol than, say, Ethernet. We also have our IO-Link product here, which we call the P2H. And again, it's IO-Link only. And we have both Type A masters and Type B masters. What is the difference between a Type A and a Type B? Well, a Type B is where you have just your logic and power going in on one cable right here. A Type A, you have your logic or your communication coming up here, and you're able to power in and power out through here. It's important to know which type of master you are using, if it is a Type A or Type B, because that's going to determine which IO-Link slave you're going to use. And you do need to be very conscious of the capacity for the current on your master. For any IO-Link opportunity, I do recommend getting your local territory manager or your local distributor involved. So let's talk about this H-Series Configurator. Why is this H-Configurator so nice? It speeds up your quoting process. You're able to get your CAD drawings right then and there, as well as this newer tool called Generate Schematics. And now I want to take a moment to actually walk through that configurator. So how do we get to that page? I'm going to open up a new web browser here, and I'm going to type in www.parker.com/PDN/H-Series-ISO. And it's going to take me directly to that home page. I do want to point out that we have recently redesigned our home pages to where on the top here is the title page. And down here, we have 3 different tabs. So let's go over the product overview. Here's going to tell you where the different applications you can use it in and what's great about this product. The tech specifications portion on here is going to give you any sort of technical information, such as any sort of specifications or certifications. It's also going to tell you the different voltages we offer and also the different protocols. Our product support tab is where you can find any sort of literature that we have published pertaining to that product. So let's go through this configurator. When you click on it, it's going to bring up this screen here. Any minute now, there we go. And right down here, you're going to be able to select this add a fold assembly by factory or this unassembled components with end plate kit. You can select either one. If you do select this unassembled components with end plate kit, Kundinger does have the ability to put together manifolds at their facility, or if you use this unassembled, it'll also generate a bill of materials that you yourself can assemble if you would like.
Yeah, and Courtney, I mean, I think I've heard in the past too that the add-a-fold assembly from Parker, I mean, it's a good service, but it can create some delivery delays at times. Whereas if we go with the other service where Kundinger does it, we typically can get the parts in and get that turned around a little quicker.
And a lot of the times you guys do stock these components as well.
Yep.
So let's pick this unassembled components with end plate kit. We're going to select a plug-in valve, meaning all the electricity is going to go through the manifold base. And after selecting that, we're going to select internal pilot in this case. In our left-hand end plate kit, here's where you'll select, if you'd like to use our P2M network node, this low profile is a great sleek looking option. I do also have a lot of people that are hardwiring use this terminal strip option, which is another great option. Let's select this P2M low profile node. For our communication protocol, let's pick Ethernet IP. And our port type NPT. Now we're able to configure our first segment. So on this drop-down menu, let's pick H1, which is the 1.1 sized valve. And we'll hit configure. Now again, we can have the option to do a blanking plate or a valve. Let's do a valve. And in this case, let's do a single solenoid or a spring assist. It's a very common configuration. Now, I do want to make this note. If you are going to be using a sandwich regulator, you must select external piloted here. But in this case, let's just use internal piloted and not use a sandwich regulator. Our voltage, we do have two different options for coils. Our standard coil is a 3.2 watt, and we do have the option of a low solenoid option or low power solenoid where it's 1.2 watts. And why is that? Some people would like to put their manifold on a IO-Link type B master where you do need to watch that power consumption. So sometimes if we use these 1.2 watt coils, we're able to meet that power consumption requirement on that type B master. So let's select 3.2 watts. I do suggest the non-locking compared to the locking override. I have gotten some complaints in the past where, oh, my valve is leaking. That's because the manual override was locked in. So let's select the non-locking, no sandwich flow control, and then the base type. Again, we do have the option to do a single address or a double address base. I recommend using the double address base unless you have more than 12 valves. And let's add that to our assembly. Now, to make things nice and easier, we have this copy feature. So if I have this same configuration in a couple different segments, what I would do to use that copy feature is I would select H1 because I got to make sure that my valve up here matches the one I want to copy into here. And then I will select copy. And here's where I'm going to type in the segment I would like it copied to. So we're in segment 1 at the moment, and I want it copied down into segment 2. So I'll type in 2 and click copy segment. And after I do that, it's going to automatically populate down here. And then if if I would like to, I would select end of assembly. And at the end of assembly, it's going to give you this option for that high flow end plate that we looked at earlier. We could do the low profile where you have no high flow end plate, or you have the option to do a 1/2 inch or 3/4 inch. So let's do a 1/2 inch in this case. And then we're done. So this is probably the most important feature of this configuration tool to speed up your quoting process. We can save this as a project and generate a new project ID. Now this ID that it generates is unique to the manifold that you just created. And you can copy this or you can email it to anyone your heart desires. So after we copy that and we email it out, what we can do is Kundinger can take that number and they can import it into the same configurator. And after doing so, click search. And what that's going to do, bear with me while it loads. And come on, my internet must be slower. It's going to automatically populate that manifold that we just created. And then we can select this summary, where at the bottom of the summary is going to generate all the different part numbers you need for that manifold if you would like to put it together yourself.
Well, and that generates a summary for us to quote as well, you know,
Correct.
So we can then quote based on that summary sheet with those parts, and then we can quote it either as individual parts or we can quote it as an assembly out of Kundinger.
Now moving back to I have it on a separate browser. There we go. So then we can get our CAD drawing right then and there as well. When we click CAD, it's going to generate this nice little window where we will have a 3D preview of the manifold that we just created. And it will pop up here in a moment. And here's that manifold that we just created. Here's that high flow end plate I was talking about, our P2M network node. And then we can download it to any format we'd like. Most requests I get is for this step file. Download it right then and there. Now, we do have this new Generate Schematics tool, which is very new. We just released it this last month, so we've been having somewhat of technical issues with it since. But bear with us because it will be up and running very, very soon. But here you're able to generate your schematics, which normally will take about 1 to 2 hours for each engineer to create schematics for their drawings. This is going to create them so you can just import them into whatever drawing you would like. So that's what I have for our webinar today. And oopsie, sorry about that. And right here is also, we're not limited to just valves. We have air prep, we have cylinders. If you have any questions, please feel free to reach out to either me or Kundinger or your local distributor. And I thank you very much for your time.